FCI Flex Connectors and Clincher Connectors, FCI. Welcome to this training module on FCI Flex Connectors and Clincher Connectors. This training module provides a better understanding of the types of flexible circuitry connectors that are available in the marketplace, as well as the latest technology that makes these connectors more versatile than ever. One of the reasons that flex circuits and connectors have become an important part of a connector world is their unique ability to fill the role of problem solver. Flex circuits can be used to bridge the gap between two boards that may not be positioned in a way that allows connection with a traditional two-piece coplanar or mezzanine interconnect solution. Flex cable can be used to transmit signals as well as small amounts of power from one board to another. Another popular use for flex circuitry is an interconnect for backlighting applications. Perhaps the most common use of a flex connector is to terminate an LCD or other display to a printed circuit board. As one can imagine, the applications for such a versatile interconnection system are quite varied, from mobile handsets and other handheld devices to flat panel TVs, medical, and industrial products. There are three types of flexible circuitry being used today. FFC, or flat flexible cable, usually consists of a flattened conductors laminated between two dielectric films. FFC is the most robust of the three types of cable with the highest current carrying capability. FPC, or flexible printed circuitry, consists of chemically etched copper conductors on a base film of mylar or similar material. This cable is a bit lighter weight and usually carries a stiffener for termination to the connector. FPC is usually identified by its brown color. Lastly, CIC, or conductive ink circuit, is similar to FPC in construction, except the conductors are a thin layer of conductive paste, usually a carbon ink material. Logically, it follows that CIC has the lowest current carrying capability. The most common cables in use today are FPC and FFC, and most connectors that accommodate one can accommodate the other. However, connectors for CIC generally require modified contacts, and as a result, connectors for CIC have a different part number than their FFC, FPC equivalents. Care must be exercised to ensure the chosen connector will accept the cable being specified in the application. Flex circuit connectors are available in both through-hole and surface mount board terminations. Additionally, these connectors are available in both right angle and vertical or straight configurations. Flex circuit connectors are available in multiple contact spacing options ranging from 1.25 mm down to 0.3 mm. There are connectors for flexible circuitry with larger contact spacing of 2.54 mm, but they are typically two-piece connector solutions. Contact spacing, also referred to as pitch, is the distance between contacts in the same row measured center to center. The contact spacing chosen usually reflects the application's demand for printed circuit board space. For example, the designer of a handheld device places a premium on getting the maximum number of components in the smallest package. Therefore, a lower profile 0.3 mm pitch connector may be required. This demand for tight packaging needs to be weighed against manufacturing's ability to process a finer pitch product. This chart shows typical pitch sizes found in various applications. The chart does not represent a hard or fast set of rules, but rather illustrates which products are commonplace by application. As one would expect, applications where size is less of an issue, such as set-top boxes and test equipment, utilize lower density connectors. Use of lower density products also results in lower costs for both cable and connector, as well as board processing. When ordering a right-angle flex connector, it's important to know that there are options for top and bottom contact locations. The reason both configurations are required is that flex circuits are usually manufactured with only one side of the cable prepared with exposed conductive material. In the illustration on the left, you can see the upper board has the exposed connectors on the bottom side of the flex, while the lower board has the connectors oriented upward. Having both options available simplifies your design and ensures that the mating contacts will be in the proper location to mate with the flex circuit. Flex connectors are available in two cable insertion configurations. The first is known as ZIF, or Zero Insertion Force. This type of connector requires very little effort, almost zero, to insert the cable into the connector. This low force results in fewer instances of cable buckling or deforming, as well as provides a higher number of mating cycles. Once the cable is inserted, an actuator is closed, holding the cable in place. The two main types of actuators are the traditional sliding type, also known as the garage door style, and the flip type. The sliding type provides higher retention and strain relief, while the flip top offers greater ease of application, making cable insertion and actuation a one-handed process. There are two varieties of flip-top actuators, front flip and backside flip. As the names imply, the actuators on the front flip style flips from the front of the connector, while the back flip has an actuator rotating toward the back of the connector. Backside flip connectors are the more popular, essentially for applications where the cable may be routed upward from the connector. This would pose the possibility of disengaging the actuator on a front flip connector, allowing the cable to be released. The second type of insertion is LIF, or low insertion force, also known as non-ZIF. This type of connector relies on the contacts to retain the flex cable after it is inserted. As a result, there is some effort to insert the cable into a LIF style connector. This also means that an LIF connector will offer fewer mating cycles than the comparable ZIF product. However, because there is no actuator required, the application process is somewhat simplified. FCI makes 0.3 mm connectors with two types of contacts, ZIF and non-ZIF. If both types of contacts are in the connector, then it is a non-ZIF connector. If only ZIF-type contacts are in the connector, then it is a ZIF connector. This chart shows a brief comparison of how the ZIF and LIF connectors with 1.0 mm spacing stack up against one another. With a more effective cable locking system, the ZIF is excellent for applications requiring a durable connector. Because no actuator is required for the LIF style product, it is less costly product that can often be made in a similar package to the similar ZIF connector. The forces driving flex connector development are similar to many other connector systems in the market. From a technology perspective, the quest for miniaturization seems to be never-ending. This is no surprise considering the number of handheld devices that utilize flex connectors. The drive for more functionality in a smaller package has affected not only contact spacing, but overall height. LCDs continue to evolve, meeting the needs for higher resolution and support of video applications. As a result, the data rates required to feed these displays must be supported by the connector interface. This is the focus of a great deal of development by connector manufacturers. Arguably, the largest driver in flex connector development is that of improved quality. This refers to the overall quality of the end device being manufactured. In other words, the operator is sure the cable is inserted properly, and the engineer knows that the connector will retain that cable over the life of the product. This slide shows a summary of FCI's most popular flex connector offerings. The Clincher 0.1 inch or 2.54 millimeter pitch connector family includes single-row pin and receptacle connectors designed for termination to flat, flexible circuitry. FCI's proven Clincher design has become the standard by which other products are judged. The addition of keying and active latching options to the receptacle offering make Clincher products the smart choice for even more applications. All receptacle connectors use the same customer-preferred and patented Clincher contact and are ideal for applications where shock or vibration are concerns. Another feature meant to address concerns with quality and reliability is reliable cable locking. FCI continues to bring advancements in cable locking technology. As a result, there are many robust offerings in the market, including many products that meet the requirements of some of the most rigorous drop tests from some demanding handheld device manufacturers. Furthermore, Clincher's positive locking, latching options assure secure mating to industry-standard headers for severe applications. FCI was the first to introduce the backside flip actuator to the market. As noted earlier in this module, this feature improves on the traditional garage door actuator by allowing the operator to insert and lock the cable in a smooth, one-handed operation. For connectors with flip-type actuation, it's not only important to ensure that the connector is easy to use, it's important that the operator knows that the mated cable is inserted properly. The innovative FCI connector body design allows the operator to visually confirm a good mate between cable and connector. As you can see in the illustrations, the connector allows the operator to see and not guess whether the cable has been inserted properly. As connectors continue to be developed with smaller pitches and lower profiles, issues regarding board processing become more prevalent. Lower profile connectors have a much higher risk of solder wicking beyond the tails and up into the mating surface. This creates short circuits and, in some cases, renders the connector mechanically unusable. In order to address this concern, FCI employs a proprietary process which places a barrier of nickel between the solder tails and the interior of the connector. This barrier prevents solder from wicking and depositing, where it can create quality problems and the need for rework.